Hello and welcome. In this lesson, we will talk about slope as a rate of change. This lesson has been prepared for students who are taking grade 9 math, but it can be enjoyed and fun to learn to math enthusiasts in earlier grades. So let's get started. Now remember that slope is a way to measure the steepness of a line. And I'm not sure if you've heard of this rhyme, but it's a very popular one. So here we go. We say that slope is easy and fun. Just remember to rise and then run. So, algebraically speaking, we measure the slope of a line by finding the difference delta y over delta x. Now, you heard me say the word delta and highlight this little triangle. As a matter of fact, this little triangle, which we read delta, is letter D in Greek, and it's used as an acronym in mathematics for the word difference. So you can also read this as the difference in the y values, which is y2 minus y1, over the difference or divided by the difference in the x values, x2 minus x1. Now, what are y1, y2, x1, x2? What do they represent? Imagine that you have a straight line on the Cartesian plane. Now, pick 2 points on this line. Now, the coordinates of one of the points will be denoted or indicated by x1, y1. And point B, will say, has the coordinates x2, y2. Now, to measure the slope or the steepness of this line, we imagine we're traveling from one point to the other, say from point A to point B. Remember that we're only allowed to rise or run, so we cannot, which means move vertically or horizontally, so we cannot move diagonally. So in order to go from point A to B, we have to rise, in this case 2 units, and run 3 units. So we'll say that the slope, which is rise over run, will be a rise of 2 divided by a run of 3. Now, if you looked at this same slope by focusing on the coordinates x1, y1, x2, y2, then we will say that the rise of 2 units comes from the difference y2 minus y1, or 4 minus 2. And that's where this number 2 comes from. And the run of 3 units comes from the difference x2 minus x1. And as you can see in here, x2 is 6, x1 is 3, and 6 minus 3 equals 3. Now, I know that you have done this in the first lesson when we learned about slope, or second, or in the unit of slope and equation of a line, but I just want to remind you of another way to find the slope of this same line by using these same points. So another way to find the slope is by traveling from point B to point A, and it's totally acceptable. So, but if you go from point B to point A, your rise will be down 2 units, so that's negative 2, and to the left 3 units, which means the run will be negative 3. So if you go negative 2 over negative 3, you still get the same slope of that is determined by the rise of negative 2 and the run of negative 3, or 2 over 3. So this is a good reminder for us to learn and understand that it doesn't matter how we travel from one point to the other on a line to determine the slope. So as long as we move always vertically and horizontally. Now, as I promised, in this lesson, we are going to look at the slope as a rate of change. Now remember that slope of a line helps us find how fast the y values are changing over an interval of x values. Now, this is called a rate of change of y values because we are measuring their speed or rate of change. Now, in this example that we just looked at, for every increase in x values by 3 units, the y values changed 2 units. So when the x values increased 3 units, which means we moved to the right, the y values increased by 2 units. Now, we are going to say that the rate of change of this line will be 2 over 3, which matches the slope of the line. Now, in other words, we're going to say that the rate of change is another name for the word slope. Now, the next thing that we are looking at is the unit rate of change. So, how is the unit rate of change different from the rate of change? Imagine that you are in a store that sells bean cans, and you can buy 1 can for $2, or you can buy 10 cans for $18. So if you want to actually decide which one would be a better buy for you, you will want to know how much each can will cost from a case of 10. In other words, you don't want to know just the price for 10 cans, but you want to know the price for 1 can. In other words, you want to know the unit price. Now, unit rate of change is kind of similar to unit price. Now, remember that we said that the rate of change is measured by the slope, which in itself is rise over run. And rise and run can be any number, except for run cannot equal 0, otherwise slope is undefined. When we talk about unit rate of change, we are looking into a specific value for a run. We want the run to be exactly 1 unit. So we're going to say that unit rate of change would equal rise over 1 unit. So, and this is what I was trying to actually explain in here. It's important to show the rate of change of y values sometimes when the x values are changing by only 1 unit. And this is what we call the unit rate of change. So let's take a look at this particular line. So if we look at this line, the green one, and we pick 2 points, A and B, where A has coordinates 2, 1, and B 4 and 5. If we want to find the rate of change, we simply evaluate the slope, which is rise over run. And for the rise, I'm choosing to go from point A to B, but as I said before, we can also go the other way around. But we're going A to B. For the rise, I have to go 4 units up. So I'm going to write 4 in here. And for the run, I have to go 2 units to the right, so 2 positive. So we'll say that the rate of change is 4 over 2. Now, if I want to find the unit rate of change, I will need to know what this fraction becomes if I make the denominator 0. Denominator 1. Oh gosh, that was not funny. So for this, what I do is I divide by the exact number I see in the denominator. And that will give me the unit rate of change equal to 4 divided by 2, 2. And 2 divided by 2, 1. So 2 over 1 will be the unit rate of change. Now, This is the formula one more time. That unit rate of change is a rise divided by 1. So let's take a look at some word problems where we can apply what we just learned. Now, Austin is in a soccer team and he runs every morning before school. One day, he ran 1,500 meters in 20 minutes. We want to find the rate of change of Austin's distance over time. So what we are trying to measure in here is distance over time. So the rate of change distance over time, or the rate of change we're trying to find in here, let's go purple this time. The rate of change will be distance divided by time. So since distance is 1,500 meters, we'll say that distance will be 1,500 divided by 20. So meters per minute. So this will be the rate of change. When it comes to unit rate of change, then we're going to say that unit rate of change equals, I will start by writing the slope as I did in the previous question answer A. And then I will divide both numerator and denominator by the value of the denominator. And that is because I want the denominator to be equal to 1. So 1,500 divided by 20, this is how I like to divide in my head. I know that we can use our fancy calculators, but whenever possible, try to do some mental math as well. It keeps our brain, on the go. So 150 divided by 2 is 75. Oops. So we'll say that the unit rate of change is 75 meters per minute. And now we'll know that Austin has been running 75 meters every minute. So if we want to graph Austin's distance over time, so here we have distance always the y values, right? So, or the dependent variable over time, then we are going to say that we don't have to go actually all the way to 20 minutes. So can go 1, 2, 3, 4, 5, 7, 8, 9, and that's 10. And every minute is 75 meters. So I would go 75 here, 150 here, 225 in here, and then here we go, 300, 375, and so on. So every minute he will go an extra 75 minutes. So it makes it easier for me to graph as well, right? So, and we can continue scaling this. And here goes the line. Now remember that we are going to start the line at 0. And just wait. Perfect. So because time cannot be negative, right? So this will be the graph that relates the distance ran over time. Now, what is the meaning of the rate of change and how does it relate to the graph? So we're going to say that the unit rate of change will tell us how many meters Austin ran every minute. Okay, let's take a look at another example. So this time we have a fancier graph in here. This graph shows the volume of gasoline that is needed versus distance driven. And we have two different vehicles. So we have vehicle 1 in blue and vehicle 2 in red. So the relationship described in here is gasoline used over distance. Okay, so I want you to think for a second, do you want to have a high or a low unit rate of change in here? So what would be that we are looking for? Now, as you can see, the blue line has smaller slope, smaller rate of change, which tells us that less gasoline is used for a certain distance or per 1 kilometer, whereas the red line is steeper, which tells us that more gasoline is used for every kilometer driven, right? So we have to calculate the slope of each graph. And for this, I have highlighted 2 points for each graph. And this is the way I like to show my work. Now I'm going to start with the red graph, and I will mark the points as x1, y1, and x2, y2. And we'll say that slope equals y2 minus y1 over x2 minus x1. y2 is 135 minus y1, which is 72, divided by x2 is 1500, oops, should have changed this, minus 800. So here we go again. We'll have in here 5 minus 2, 3, and 13 minus 7, 6. And 1500 minus 800 is 70. So we'll say that the slope of the red graph is 63 over 70. Now let's take a look at the blue graph. And for the blue graph here, we have 2 points, which again will mark as x1, y1, and x2, y2. So slope would be equal to y2 minus y1, x2 minus x1. So y2 is 90 and y1 is 48, divided by 1500 minus 800. As you can see, we have found the rate of change of y values over the same interval in x values of 1500 minus 800. Now 90 minus 48, think 90 minus 50, 40, but with a 2. So that's 42 over 70. Now, in the next question, we have to interpret the slope as a rate of change. So for the red graph, we are going to say that the rate of change equals 63 over 70. It's exactly the same as the slope. For the blue graph, we're going to say again the rate of change is 42 divided by 70. Now the next question is probably the more fun question. We have to find the unit rate of change. Now for the unit rate of change, we will have to divide by the denominator. So I will divide by 70, both numerator and denominator, so that I can have the denominator equal to 1. And 63 divided by 70, they both have the same common factor of 7. And if you use a calculator, and that's what we're supposed to do at this point in time, we find that 63 divided by 70 is 0.9. So we'll write 0.9 liters per every kilometer. And for the blue graph, unit rate of change is 42 over 70. We'll divide both numerator and denominator by 70, so we get to have the denominator equal to 1. And that will give us 42 divided by 70 equals 0.6 over 1. So 0.6 liters will be used for every 1 kilometer distance driven. So this was the lesson about the rate of change, or stop as a rate of change, and unit rate of change. So two main things we need to remember. The rate of change is just another name for slope, and it describes how fast the dependent variable is changing over an interval of change of independent variables. And the second thing we need to remember is that the unit rate of change is rate of change but described with a denominator or brought to denominator of 1. So, and that's what we were explaining in here. So I hope that you enjoyed this lesson, and I hope everything made sense. We have some practice questions to work on. And bye for now. Thank you for listening and learning from me.